Hello super students and welcome to the Mineral Lab. I noticed that I have a lot of pieces of paper here, and the first thing I'm going to do is realize that my minerals are numbers 1 to 20. So I'm going to cover up the rocks with a thing that says rocks. The next thing I'm going to do is get my tools for identifying minerals all set. To identify minerals, you need a streak plate, and I'm going to hold things a little further away this time so they're in focus. We have both a white and black streak plate because some minerals will leave a visible streak behind. We also have a glass plate to check for scratching for hardness. You're supposed to have a steel nail or file. I have a push pin that's steel, so we can see if steel will scratch something. I have a little magnet here to see if stuff will be attracted to magnets, and I have a penny. And those are my tools, and I'm going to set them all. Okay, there. Now we have the whole kit. I can move the rock thing down a little bit so that you can sort of see the minerals. And I've got a magnifying glass and all the tools laid out and ready to identify some minerals. To do this, we're going to be using Mohs hardness scale. And if you don't know about Mohs hardness scale, you need to do the rock lab, because this is where I talked about the rock lab. Should have talked about it here in the mineral lab, but I talked about it in the rock lab. You know, you're not paying any money to watch these videos, so I'm going to go with, hey, it's my mistake. And we're going to use, again, a dichotomous key. In this case, we're going to start out with whether it's metallic, non-metallic dark, or non-metallic light, and then we'll go through different things and see if we can identify some of these minerals. The sheet that you'll be using is this one, and yours will be, I think, a little bit more colorful on the computer. Notice the ones that are highlighted in yellow. These are the metallic minerals. Sometimes it's hard to tell one that's metallic or not. So we've got all of this, and we are ready to start identifying minerals. Okay, so we'll get this out of the way. We'll leave Mohs hardness scale there handy. And we'll start with the first mineral, which is a kind of difficult one to identify. One of the properties you're looking for in minerals is a thing called cleavage. And cleavage is breaking along flat, straight planes. Color really isn't a big benefit. Hardness is, whether it's magnetic or not, and this one's not. This one, will it leave a streak? No, that's strange. It did leave a streak, but it should not leave a streak, either on the black or the white. So let's start using our key and see if we can figure out. First of all, it's definitely non-metallic. I would say it's light in color. Now, it's hardness. It's definitely harder than my fingernail. Can I scratch it with the steel? And my first thought is no, it does not scratch easily. So it's harder. I've decided that it does have cleavage, this breaking along flat planes. And then we have striations and no striations. Striations just kind of means little stripes in it. And this one, I wish I could get it close enough for you to see, but it does have them. So if I follow the striations, I discover that it's plagioclase feldspar. There's two types of feldspar, plagioclase and orthoclase. And this one is the plagioclase feldspar. So then, the next step is to go to the chart. And there's my plagioclase labradite feldspar, and that's where I'm going to put a number 1. And we have begun identifying minerals using these various properties. I didn't go through all the properties or teach you about minerals to begin with. I'm just kind of teaching as we go, and hopefully that will be okay. I'm going to put the hardness scale aside there. We'll put our feldspar back. And we'll go with number 2, kind of a dark Angular. It does have these kind of flat surfaces, so maybe there's cleavage, but maybe not. And so this one, let's see, the same kind of not real streak. I think what I'm actually doing is scratching the porcelain. With a dark one like this, you'd want to use, and there's nothing on the white. Can I scratch glass with it? I'm not sure it's hard enough to scratch the glass. Doesn't seem to be. I think I can scratch a piece of copper with it. I don't know if you can see that, but I definitely left a nice scratch on the penny. And pennies are copper-plated zinc. They used to be bronze, which was mostly copper, but now they're not. But the surface is still copper, so it works. Is it magnetic? No. All right. Non-metallic, dark. Harder than a steel nail, and I think so. And I realize at this point this is a very tough one to identify, because basically it ends up giving you olivine. And the problem is this is a sample of a material that should be much lighter. So really we follow the light path, and it's supposed to have good cleavage. So we're down here, and it turns out it is the other type of feldspar. In this case, it is called, I think, labradite. So not a great sample, or not labradite, that was the one we had, orthoclase. This is orthoclase feldspar. So that's number 2, and that is a really hard one, and I'm glad we're past it. This next one is really, really easy. You've probably seen people wearing these as necklaces. There is definitely no streak. Oh, hey, I have my magnifying glass, which I'm hoping that's magnifying it for you and making it look cool. So this is a clear crystalline material. And the neat thing about this is it absolutely scratches the glass, which means that it has a hardness of 7 or greater. And I noticed that it says quartz is 7 and scratches window glass. And so that's going to be my first guess, is that this may be a piece of quartz crystal. We see these flat surfaces, which could make you think that it has cleavage properties. And you would be right in assuming that. But if I take it and hit it with a hammer and break it, and that's where I can look here and see where there's a break. Okay. Maybe you can see that break. It's not, if it really showed cleavage, it would break off in the same flat shapes. This doesn't. This breaks like a piece of glass, what we call conchoidal fracture. And so it does not have good cleavage. So let's go to the chart. Not metallic, let's see. It is non-metallic, it is absolutely light, it is harder, it doesn't have cleavage, and that takes us right to quartz. And so, the quartz is with us. So we'll have to find quartz on here. We have 2. There's Quartz Crystal and Milky Quartz. This is the Quartz Crystal. So that's where I'm going to put my 3. And I'm going to set my quartz back. I'm going to grab this funny white thing. And again, let's try a streak. No streak on the black. Of course, with a white material, I should try the black streak plate. Black streak plates are new. I'm kind of excited about this. And again, it looks like it's leaving a streak, but it really isn't. And that's confusing. I need to show you something that makes a serious streak, so that this is another mineral, and it does make a streak. There we go. Okay, you can see? All right, hi to you. See, that's what a streak is like. That's what it means when a mineral makes a streak. You can actually kind of color the thing in. All right, so we'll put that mineral away and go back to identifying this one that has no streak. So let's go through our hardness. Let's scratch a penny. Yes, scratches the penny really, really nicely, which is not good to deface federal property, but you know, that's, sorry, I don't have lovely samples of copper. My steel push pin is no effect on this. It's not magnetic. And so, light color, harder than steel. It's definitely got breaking conchoidal fracture again. It's not, doesn't show good flat planes at all. So no cleavage. This is again another form of quartz. In this case, this is Milky Quartz, and it's exactly the same as this crystal. The only difference is this has little air bubbles in it. And you've seen the same phenomena with something much more familiar. Sometimes you can freeze an ice cube and get it to be absolutely clear. Other times, most ice cubes end up looking like this because of the air bubbles frozen in them. The same thing is happening here, but it happened at much, much higher temperatures. This solidified with air bubbles in it, that solidified without. Quartz crystal, Milky Quartz. All right. The next thing is not going to look, it's going to look like I have pieces of plastic in my hand. But it turns out this is a mineral, and I have better samples to show you. Don't go away. Like so magically for you, it probably looks like a brown bag just appeared. I had to walk over to the demonstration desk to get this. I'm going to just use the rock thing because I think you can kind of see that to pour these out. And then I'll try to get a good sample to show you. So you can see that I got these from a mine in North Carolina, a little place called Montreat. And it's shiny, it's flaky, and this is the best way for me to show you cleavage because I can dig my fingernail in there and see what happened? It just peeled apart. So that means the molecules are bonded really strongly in one direction and really weak in the other. And so this has really good cleavage in across one plane. This is a lighter type of mica. Okay, so I gave away the name. Sorry, this one's mica. We didn't identify it, but it's okay. You're gonna get all the answers anyway. So that's Muscovite Mica, and then this really dark black one is Biotite Mica. So there's two types of mica, and they can be in big, clear, beautiful sheets. And mostly they're the things that add the sparkle to a lot of the rocks that we end up seeing. If you remember the mica schist from last time, it's this stuff that's on it. Well, not that. So that's the mica. We'll just let it sit there and look pretty on top of the rocks. And if we wanted to go here, I think it was light, and it would be fairly soft. Softer than a fingernail, actually. It has extremely good cleavage, thin sheets, and there's our Muscovite Mica. Okay, so mica is number 5. So we'll go to the chart and see if we can find mica. You guys are probably finding it a lot faster than I am. Muscovite Mica, right there, number 1. So we'll put 5 there. And I don't think I put Biotite Mica. Well, yeah, you don't have that. You only have Muscovite. So you got to get an extra mineral by watching the video. My students in class won't get that. They're excited, I can tell. Okay, this next one is kind of a, it is really pretty. It's shiny, it's black, it kind of, to me it looks like a city that Superman would live in, but that's just my crazy sci-fi stuff. But it's very black and shiny and got all kinds of little, it sort of does seem to have the striations. We'll try the streak. It's dark, so we'll try the, I got nothing, no streak. Can it scratch copper? I would say yes, it can scratch copper. Steel, I think the steel might be able to scratch it. All right, let's see if we have some luck here. So non-metallic, dark in color, harder than steel. And I'm thinking it isn't. I'm going to go softer than steel. I really can't tell cleavage. I do see some flat planes, so I'm going to guess good cleavage. But then, okay, white streak, green streak, red streak, yellow. So I must have gotten in trouble because there's no streak at all. So let's go back to harder than steel, good cleavage, and I get hornblende and agate. And it's in two directions, 56 and 124 degree angles. And that is the kind of angular thing that we're seeing here. So this is hornblende. It's what makes the black specks in granite. Hornblende is number 6. Funny name. Hornblende's number 2 on the chart, so we'll put a 6 there. In case you need help catching up. All right. And this is one of my favorites. Okay, this, when it's clear, you can see through it, and if you look at text through it, it actually doubles the text. When it does that, it has a special name called Icelandic Spar. But look at the flat surface here, the flat surface here, the flat surface here. It sort of has a parallelogram shape. This is just screaming out to me that it has good cleavage. If I hit it with a hammer, all of the pieces would break off and be little parallelograms, just like this. It is fairly soft. In fact, the copper coin will actually scratch it. So it's softer than the copper coin. And that should be enough for me to identify it. So we have non-metallic, light in color, and we decided that it was softer than copper. So softer than a nail, harder than a fingernail. It has really good cleavage. And okay, so non-cubic cleavage. This one does react with hydrochloric acid. If you poured hydrochloric acid on it, it would fizz. And that means that this is calcite. And calcite's pretty darn important. It's CaCO3. It's the same thing your bones and teeth are made out of. But when it's in the ground and it gets a chance to crystallize, it does this amazing thing. And in some cases, there are just beautiful samples of calcite out there. And I'm sorry I don't have a good one to show you. But I have this one. Okay, so calcite was number 7. We find calcite on the chart, and it's number 3, so put 7. It's kind of looking like there's a pattern going here. All right, the next one we want to look at is this one. It's kind of got some red and green to it. It's got a little bit of sparkliness to it. In fact, with the magnifying glass, you may be able to see some more of the, there is some definitely some, they're small, but they're really pretty little crystals in here. And these two interesting colors. So let's see if it's got a streak. No streak. No streak. Can I scratch it with the nail? I'm saying no. Is it magnetic? No. Can it scratch glass? I'm going with no. Okay, so now we have to decide is it dark or light. It's really kind of in between. So I'm going to pretend it's light, unless I can glance over, because I know what it is. So the nice thing is I can look over and see the answer, and it turns out it's dark. And it's going to be harder than our steel nail, and it actually doesn't, you can't see it here, but it doesn't really have good cleavage. So we're going to go with no cleavage. And then we've got red to brown in color or dark to light green. This is mostly red. So if I follow the red, this is a sample of garnet. It's a semi-precious gemstone. If we had a prettier sample, it's something that you could actually cut and turn into a form of jewelry. When you see the gem and mineral video, you'll see some absolutely beautiful garnets. But this is our sample of garnet, and so darn it, that's garnet. Okay, so number 8 is garnet. I'm going to put an 8 down on the chart. I don't know if you need to see me do that, but we do seem to have a run going up here, 5, 6, 7, and 8. Maybe the crazy teacher had some kind of pattern going when they made this, which is me, and I made this. All right, the next one we've got is, I think this may be one of our first metallic ones, because, let's see, that's, if I've highlighted the metallic ones here, that doesn't really help you very much in knowing what it might be. But since I think it's metallic, oh, did you see that? This is magnetite. I don't need to do any more tests with it. It is definitely attracted to a magnet, and in fact some magnetite it's magnetic itself. It cooled in a place where there were strong magnetic fields, and then it is just a natural form of magnet. So we don't even need the sheet, but it would be up here in our metallics, and the first branch is magnetic, and boom, you go to magnetite. All right, so we have our magnetite iron ore, and that's number 9. Okay, this next one has all kinds of pretty sparkly things going on. I'll give you the magnifying glass treatment to see if it, I hope it comes out and looks as pretty as it does in person. There seems to be an intrusion, a layer of something else running through it, but mostly it's very dark and big crystals. We'll try it on the white streak plate. Ooh, we had a pretty neat brown streak there. Just for fun, we'll try it on the black one. Really obvious brown streak. That's cool. I didn't expect that. I always have the students do it. I never get to do it. This is kind of exciting. Sorry you're not here getting to do it with me. All right, so how about hardness? Let's see if it'll scratch the penny. All right, Abe, sorry about this. Yeah, it scratched Abe. Well, I didn't actually hit Abe, I hit the other part. So it's harder than copper. And I feel like it's harder than the steel, although as I drag this along, I'm getting that same brown residue. So it may not be harder than steel. And can it cut glass? No, the glass is impervious to it. So it's dark, non-metallic luster, okay, non-metallic dark color, harder than steel, softer than steel, and I'm gonna go with harder. Okay, let's go with the streak. Red to brown in color. Oh, that's not our streak, that's the actual color. They don't give us the streak. Okay, down here it does. This one has a red-brown streak, but it's hematite. So I'm having trouble with number 10 because I know this isn't hematite. I know it's not limonite. I'm not sure why there's a feldspar box there. Okay, this one is tricky because it is harder than the steel nail. It doesn't have cleavage, and it's got this dark to light green. So I don't know if that's actually part of it, but I added a thing over here that says safflorite zinc ore. And that's what this is. This is a mineral that they will grind up and melt and get the element zinc out of. So zinc sapphirite is number 10, and zinc ore is down here at number 18. So I'll put a 10 there. All right. This is a metallic one, and in fact, it looks very similar to our magnetite. So that's kind of a clue to it, but it's not a good clue. It actually, if we look at it closely, this isn't a great sample of this one, but it has a goldish, tarnished looking appearance, and in some cases there's some beautiful blues and greens and golds all mixed together in samples of this stuff. So it's metallic, it's non-magnetic, it's gold in color, it is tarnished. This is Calcopyrite, a copper ore. So Calcopyrite. Find Calcopyrite on the list. It's down at number 19, so I'll put an 11 there. All right, this is where I got confused. This one does look like this one. They both have kind of sparkly gray. This one, not magnetic, however. But metals, the metallic ones are easy. It's not magnetic. Does it have a streak? It says it might have a silver streak. Huh. I would say that looks a lot like a brown streak to me. So, silver in color, red-brown streak, and that makes it a thing called hematite. Hematite is an iron ore. For instance, you might know that your blood has a thing in it called hemoglobin, and that's the red blood cells carry a molecule with iron in it. So this is hematite, it's an iron-bearing ore, and hemoglobin is in your blood and carries iron. That was number 12, and it's the iron ore. And I can't seem to find it. There it is, the very last one, hematite iron ore. Hematite can be polished and look really, really pretty. Those little magnets you throw together and go click, click, click. That can be done with hematite. Okay, this next one is super silvery, super shiny, really, really heavy. And I think it's going to do a nice job giving us a streak. A nice silver gray streak. And I have another sample of the same thing. It's a little bigger version. If you ever come into my classroom and pick this up, it is enormously heavy. But these two are the same thing. And notice the flat surface here, the flat surface here, flat surface here. If I broke this apart, I would end up getting lots of little pieces with the same cubic cleavage. So this is one that does have good cleavage, but I don't even know if that's a thing we have to worry about here. So we got metallic luster, non-metallic, silver in color, harder than a fingernail, and we got a black streak, I guess. I thought it was gray. So this is galena. It's a lead sulfide. It's an ore of lead. It's lead and sulfur combined together, and it makes this beautiful, shiny, dense, heavy silvery stone, galena. So galena is number 13. And now I just have to find galena's down at 17. So at 17, I put a 13. And we're getting the mineral lab done. All right, the next one is perhaps the ugliest one I have in the kit. I mean, this thing is, I don't know, maybe under the right circumstances it could be pretty, but it just looks like a hunk of rust. I'm guessing it's going to give us a red streak. Yeah, not an easy one, but a reddish streak. Not magnetic. I think it did scratch the penny, but I don't think it's gonna do anything with the steel. So let's see if I have enough information to figure out this thing. I think it's dark colored. I think it's softer than the steel. I don't think there's cleavage. We got kind of a red-brown or maybe a yellow-brown streak. And that would make this one limonite. Let me just check to make sure. I don't want to steer you wrong. Yeah, this is an iron ore and it's called limonite. So I guess that's why it looks like rust. Limonite is number 6. And so number 6, I'm putting down 14. And we're ready to move to the next mineral. This one is truly unique. It seems, if you remember conglomerate back from the rock lab, this looks similar. It appears to have these little circles of other something in it. In mineral terms, we call these nodules. And that is the giveaway one for this, because you could do all this testing, but when you find out that it shows nodules, and I'm trying to find where on the sheet it shows that. I remember my students always raise their hand and go, Mr. C, what are nodules? Okay, so if I'm down in non-metallic, light in color, and I can't find the nodules to show you. That's terrible. I'll have to go backwards. Okay, there, right there, contains nodules. I found it. This is bauxite. This is an amazingly important mineral. This is an ore of aluminum. And aluminum used to be more expensive than gold. There's actually a chunk of aluminum in the Washington Monument because they thought it was so valuable. This incredibly strong, incredibly light metal, but it's really hard to refine it. Copper, iron, you just heat it up, it comes out in the melt, and you pound it with a hammer for a long time, and you eventually with iron can get steel, and with copper you can get various copper alloys. But this one, not so easy. This one you have to melt and then put high voltage electricity, 2 electrodes in, and all the aluminum goes to 1 electrode. So it's very expensive to actually make aluminum, but we've gotten easier at making electricity. Bauxite is widely available, so now we have it in our drink cans, but we make airplanes out of it. We wrap old food in it, aluminum foil. Bauxite, really, really incredibly amazing. And there was a teacher who told his student, if you figure out a way to refine this and make aluminum cheaply, you'll be rich. And the student in the class did exactly that and became very rich. So I don't have any good advice for you like that other than keep learning. Always be curious, because there's an amazing world out there of things to discover. Bauxite is number 7. I'm going to put a 15 by it and go on to our next, and one of my very favorites. It has a beautiful gold color to it, even though it's not a great sample. But if under the magnifying glass, there's some sparkly bits here that I'm hoping you're able to see. And there, I'm going to look because it's just fun. So, let's see. Will it leave a gold streak? It doesn't. Isn't that weird? It's gold, but it leaves a black-gray streak. All right, well, this should be pretty easy because it's metallic. So we're going to go metallic luster. It's not magnetic, gold color, and normally it would be bright and brassy, and parts of it are. And this is iron pyrite, also known as fool's gold. So for iron pyrite is number 16, and we will put that's at number 8. Fool's gold, iron pyrite. Yeah. This is fun. It looks like a cube, doesn't it? This has outstanding cleavage. It's clear, and sometimes before COVID I would tell my students to lick this, and then we'd rinse it off, of course, so no one got sick. But Well, let's try with the chart, see what we get. Okay, it's non-metallic, light in color. I can't scratch it with my fingernail, but it definitely, so I'm thinking it's harder than a fingernail. It has cubic cleavage, and that means it is halite. Halite is the fancy mineral name for rock salt. That's a hunk of salt that ended up forming into this beautiful crystal that we have in the set. And if you licked it, it would taste incredibly salty. Halite, rock salt. And that's number 17. So halite is at 13. I'll put a 17 there. Okay, so just in case you're falling asleep and missing some of it, there's the numbers for you. And of course, you can pause the video if I'm going too fast. But I feel like I'm boring, and I hope I'm not. I so wish you were here to play with this one. This is so much fun. It is real slippery feeling. This one makes the best streak of all. I'll use the edge because it's clear. But I don't even need a streak plate to make a streak with this one. I'm going to take my lab and I'm going to draw a line right down here. I just did that with this mineral. This is a mineral all of you are familiar with. This is one that all of you have, whenever you've been stabbed by a pencil, you probably said you had lead poisoning. Well, this isn't lead though. This is pure carbon and it's called graphite. Now, if we followed, I cheated, I just told you the answer, but I think you would have figured it out pretty fast if you were here. So graphite is a metallic, and it's not magnetic, it's silver in color, it's soft, and so you go right to graphite. So it's pretty easy, although deciding that it's metallic is kind of hard, because at first you look at this and you think, wait, is it metallic or not? It's kind of on the edge, kind of in between metallic and not metallic. All right, so graphite is 16, 17, it's number 18. So I find graphite on the chart. Maybe I'll find graphite on the chart. There it is. Oh, it's not, it says not on the key. I just found it on the key, so it's on the key. That's an error I need to fix. Okay, we are down to our last two minerals. This one, you've actually already met in a movie. It is soft. I can cut it with my fingernail, use my black streak plate, and get a very obvious white streak from it. So with that, let's see how we do. It is non-metallic, light in color, softer than a fingernail. Cleavage, I have no idea, but it kind of has a, it doesn't feel too slippery. Okay, I can get these two confused. All right, I'm messing up here. You haven't met this one yet. This is one that they used to crush and turn into baby powder. And so this is talc. So if I had done it right, softer than a fingernail, it would feel slippery and it could be light colored, and that gets us to talc, which is what they make talcum powder out of. But talc today we've learned is bad if you inhale the vapors or the powder from it. So we don't want to inhale that powder. So talc is 19. I'm going to put 19 at talc. And we have one left, and I only have one blank left. So this is the one that you saw in the crystal cave. This isn't nearly as pretty as their samples, but this is gypsum. It should also give us a light streak of, okay, bright white, easy streak, and very soft with your fingernail. But still, you know, it's a nice, healthy rock. And so it's gypsum. if we use this, we go softer than a fingernail, no cleavage, non-slippery, white, alabaster, or gypsum. So gypsum, I'm going to put where gypsum is, 16. I will put number 20, and that concludes our minerals. Although I see where I made one error, so I'm going to pause this, fix the error, and then show you the results. All right, I forgot to put Milky Quartz down and then ended up writing halites number 17 there. But there's your complete answers. We have done the mineral lab together, and I hope that you were able to learn a little bit by watching this. Thanks for watching it if you did watch all the way through and didn't fast forward. I appreciate you learning out there, and I look forward to someday seeing you live and in person here.